You know that feeling? When you're trying to get up to speed on some really complex topic in AI, sifting through all the articles, research papers, your own notes, maybe it can seriously feel like tumbling down an endless rabbit hole. So, here on the deep dive, our mission really is to take that whole stack of sources and just give you the ultimate shortcut, help you get truly well informed. We try to throw in some surprising facts and hopefully just enough humor to keep you hooked along the way. Okay, so today we're diving into something genuinely fascinating. A new development in artificial intelligence that, well, it directly challenges a really fundamental assumption about how these powerful models actually work. And I mean, this isn't just some minor tweak, it feels like a potential game changer for how we think about AI's ability to not just create outputs, but also to, critique itself rigorously. We're going to unpack a pretty groundbreaking paper. It's titled LLaVA-Critic-R1. Your critic model is secretly a strong policy model. Now here's where it gets really interesting, I think. Traditionally, AI models have been designed with this clear division of labor, right? You've got models built to evaluate outputs, think of like a discerning critic, and then separate models designed to generate responses, more like a creative policy writer. But this new research reveals that actually a single model can do both. And not just do both, but do them exceptionally well. Imagine if your, brilliant Michelin-starred chef could also be the most insightful, discerning food critic, all in one person. That's the kind of unification we're talking about here.
That analogy actually captures it perfectly. For a long time, particularly in the specialized world of vision language modeling, VLMs, this separation has been, really entrenched. You had the critic models, trained to give scores or rank preferences, and then the policy models, which actually write the responses. And the assumption was just, these critic models weren't really cut out for direct generative use. They had their job, evaluation. This paper, though, it just fundamentally shatters that convention. It uncovers this surprising but really effective unification. So yeah, our deep dive today is built mainly on insights from that primary ArXiv paper by Xiao Wang and 6 co-authors. We're also bringing in context from the big Reinforcement Learning from Human Feedback book, the RLHF book, which is crucial background here. And also looking at the practical side, the developments shown in the LLaVA v LLaVA Next GitHub repository. Put together, these sources paint a really clear, multifaceted picture of what's a pretty significant advance.
Okay, right. So let's really unpack this core finding then. The paper calls it a surprising empirical truth. Basically, a critic model, which you normally just think of as an evaluator, can actually be transformed into a strong generative policy model. And not just strong, but with significantly improved capabilities. So it's not just judging anymore, it's becoming a powerful creator and editor all rolled into one. How did they actually achieve that unification in practice? What did they do differently with the data to break that old mold?
That's the key question, isn't it? Because the how is where the real innovation lies. Their core strategy was essentially to reorganize existing data sets. These data sets already had preference labels, response A is better than response B, but instead of just using them for evaluation, which was the old way, they cleverly transformed them to verifiable training signals for a generative model. It's like taking a pile of restaurant reviews, and instead of just seeing which dish won, you figure out why it was better, and then teach a chef how to cook specifically to meet those winning criteria.
Ah, okay, so they're repurposing the evaluation data for training generation.
Exactly. And then they applied reinforcement learning, RL, directly onto a base generative model. For this specific study, they picked the Qwen 2.5 VL7B model. It's a 7 billion parameter vision language model, a solid foundation. And to guide that RL process, they used a technique called Group Relative Policy Optimization, or GRPO. Now, for anyone familiar with RLHF reinforcement learning from human feedback, GRPOs is known to be pretty effective. The reason is it learns by comparing multiple potential answers to a single question, all within the same batch. This lets the model really refine its understanding of what makes the response better, not just in isolation, but compared to other options.
Right, like getting feedback from a whole panel comparing different versions, not just one rating.
Precisely. That group comparison is absolutely crucial for how it sharpens its judgment and generative ability.
That's fascinating. So it's learning the nuances of quality through comparison. But okay, beyond just judging better, how do you teach it to actually, think and then generate these brilliant, well-reasoned answers? Is there more to it than just the data setup?
Oh, absolutely. The intelligence isn't just in the raw data. It's very much in how they structure the learning process. And critically, it's in the specialized prompt templates they designed. So for building the critic training data, they used a template that presents the model with, say, an image and a question. Then it gets two different responses and has to choose the better one, or say they're equal. This directly hones its evaluative skill.
Okay, standard critic training.
Right, but here's where the magic for generation and reasoning happens. For the RL training itself, and also later when you actually use the model at inference time, they use this thing called the thinking template. This template explicitly instructs the model to first work through the reasoning process. It's like an internal monologue, and it's enclosed in special tags. Think and think. Then, only after it's done this internal thinking, does it give its final answer, usually inside a box. This isn't just window dressing, it's a really critical technique. It encourages explicit step-by-step chain of thought reasoning.
Wow.
Yeah, it makes the model's cognitive journey transparent instead of just spitting out a black box answer.
That's incredibly insightful. So it's not just giving the answer, it's literally showing its work. Like you said, laying bare its cognitive journey. That really does sound like a massive leap for, explainable AI, more trustworthy AI. For you, the listener, think about it. It's like that math student showing their full working out, not just the final number. You can actually see how it got there.
Precisely. And that transparency is just invaluable, not just for understanding why it made a decision, but for debugging it, refining it, and ultimately building more trust in these systems. It definitely moves us away from just getting an output towards understanding the reasoning behind the output.
And the results. You mentioned they were surprising. LLaVA-Critic-R1 didn't just become a good policy model, it became a top-performing one, right? While still being a great critic. It's like that gymnast analogy, judging accurately and winning gold medals in different events.
That's absolutely correct.
Yeah.
The performance was, frankly, remarkable in its versatility. It consistently matched or even surpassed specialized reasoning VLMs models that were specifically trained with tons of in-domain data just for reasoning tasks. Across a broad set of 26 different visual reasoning and understanding benchmarks, LLaVA-Critic-R1 achieved a really impressive average gain of plus 5.7% over its base model, the Qwen 2.5-VL7B.
Plus 5.7% across 26 benchmarks is significant.
It really is. And they didn't stop there. They pushed it further, developing LLaVA-Critic-R1 plus EAT. This enhanced version managed to boost the policy performance even more without hurting its critic quality. And it achieved what was, at the time, a state-of-the-art performance of 71.9 on the really tough MMMU benchmark at that 7 billion parameter scale. Now, MMMU, for those who don't know, is this incredibly rigorous multimodal benchmark. It tests reasoning across like 30 different subjects, art, physics, you name it. Hitting 71.9, there isn't just a technical win, it signifies a really dramatic step forward in unifying these two capabilities in one model. The gains are substantial.
Okay, so we've got this unified model, creator and critic performing incredibly well. But you mentioned something earlier that sounds maybe even more valuable, especially for the user. You said its enhanced critic ability benefits performance at inference time, meaning when you're actually using it. So it gets smarter, more accurate, without needing more training. How does that work?
Yes, this is a really key empirical finding from the paper, and it has huge practical implications. They found that simply applying this self-critique capability at test time when the model is generating answers yielded an average improvement of plus 13.8% on 5 key reasoning tasks. That's a big jump. What's happening under the hood is the model essentially generates multiple possible responses internally, and then, using its own finely tuned internal critic abilities, it evaluates those options and selects the absolute best one to present as the final answer.
So it generates a few drafts and picks the best one itself.
Exactly. It's acting as its own quality control. This whole concept aligns really well with techniques you see in RLHF literature, things like rejection sampling or best of n sampling. In those methods, you often use a reward model, sort of an external judge, to filter candidate outputs and find the highest quality ones. Here, the model is using its own integrated critic function to do that filtering. It also connects to broader ideas people are exploring, like inference time scaling or sharpening mechanisms. The basic idea is that if you spend more computation time at the point of use, you can often get significantly better results. And the paper shows this quite strikingly. Performance on benchmarks like MMMU just keeps climbing as they increase the number of candidate answers the model considers for self-critique.
Wow. So wait, you're telling me this AI can literally review its own generated work, weigh the pros and cons of different answers it came up with, and then pick out its best one all on the fly? That's not just an incremental improvement. That sounds like a leap towards much more reliable AI. Like it has its own internal editor.
Precisely. It's not just generating, it's intelligently evaluating its own generations in real time. It dramatically reduces the chance of it giving you a rushed, suboptimal, or just plain wrong answer.
Okay, let's make this even more concrete. Can we walk through that example from the paper? the one about the movie box office, I think that really helps illustrate the difference this unified approach makes. So the question was something like, you see an image with box office data, and the question is, according to the image, in 2018, did Avengers: Infinity War achieve the highest box office revenue in North America?
Right. So when the base model, the Qwen 2.5 VL7B thinking model, tackled this, its internal think process noted Avengers: Infinity War was near the top, with 678.82 million USD. Based on that, its internal thought process concluded essentially, yep, looks like the highest. And so its final answer was boxed yes. Quick seemed reasonable maybe at first glance, but ultimately wrong because it missed a crucial detail.
It made a mistake. But LLaVA-Critic-R1 plus B, the enhanced unified model, got it right. It answered no.
It did. And this is where seeing its think process, its internal monologue, is so revealing. It clearly shows the model breaking the problem down. Step 1. Identify the actual highest revenue movie on that chart. That was Black Panther. It's 700.06 million USD. Step 2. Then it explicitly compares Avengers: Infinity War's revenue, 678.82 million, to Black Panther's, 700.06 million. Only after doing that direct comparison does it correctly conclude, boxed no. It demonstrates real multi-step logical reasoning and that critical comparison step, not just pattern matching or grabbing the first prominent number.
That example really does bring it to life. It's the difference between that quick, confident, but wrong answer and a thoughtful, methodical, accurate one. It really shows the power of being able to reason critically, not just retrieve info. That feels like a huge step towards AI you can genuinely trust with complex questions.
Absolutely.
Yeah.
What really emerges from this deep dive, from this research, is that story of breaking down a long-held barrier. For ages, the assumption was separate brains needed for creation and critique. This paper shows empirically that's not necessarily true. It demonstrates that reinforcement learning on critic data can produce a unified model that truly excels at both evaluation and generation simultaneously. That's a fundamental shift in how we might think about architecting these AI systems.
So it changes the blueprint, potentially?
It could. And if you connect this back to the broader picture of RLHF, reinforcement learning from human feedback, this work offers what the authors call a simple path towards scalable, self-improving, multimodal systems. Think about it. The ability of a model to internally critique and refine its own outputs is an incredibly powerful form of built-in feedback loop. This internal process, well, it has the potential to make AI development much more efficient, more effective. And maybe, just maybe, it could significantly reduce the need for that really extensive, often costly, human labeling process that's central to current RLHF, or at least make human feedback much more targeted.
Because the model starts providing its own high-quality training signals, in a sense.
Exactly. It learns to improve itself from its own internal evaluations.
So wrapping this up, what does this all mean for you, the listener, and just the general path of AI innovation? This research seems to suggest we're moving towards AI that isn't just smart, but maybe self-aware isn't quite the right word, but functionally self-aware, capable of examining and improving its own work.
I think that's a good way to put it. Functionally self-aware of its own output quality.
We've seen how LLaVA-Critic-R1 isn't just some technical feat. It feels like a really profound conceptual leap. It's blurring those lines between an AI's ability to create and its capacity to critically evaluate. It definitely signals a shift towards models that can learn to improve from within, a continuous cycle of self-refinement.
Which does raise a really interesting, maybe even compelling question for you to ponder as we finish up here. As these AI models become more unified, capable of both generating incredibly complex stuff and then rigorously assessing their own quality, what new forms of intelligence might actually emerge from these integrated capabilities?
Yeah, that's a big question. Will this unification accelerate the development of genuinely autonomous AI agents, ones that can continuously learn and refine themselves without needing constant human handholding? And, what does it mean for our interaction with these systems when they can not only answer our questions, but also proactively improve their own answers through this internal self-critique, almost like they're thinking aloud and correcting themselves right in front of us? It's a thought that really makes you wonder, doesn't it, about the next frontier of AI and what interacting with these self-improving minds might actually look like.